This video is on factored versus standard form of quadratics. We are going to do 4 examples of rewriting the problem into the specified form, finding the x-intercepts, finding the y-intercept, and finding if it's a minimum or maximum. So this question 5 asks us to rewrite the problem into standard form. That means that we should be in factored form right now, which is also called intercept form. So to put into standard form, we need to distribute. This squared, if we remember the definition of an exponent, means that we have 2 factors of x minus 6. So with 2 factors of x minus 6, we would rewrite it as x minus 6 times x minus 6. Now that we have it rewritten, we can distribute this so that we can put it into standard form. So we'll take the x times our x and x times negative 6. We will also take our negative 6 times x and negative 6 times negative 6 because we distribute the entire first set into the second set of parentheses. X times x is x squared. X times negative 6 is negative 6x. Then we take our negative 6 times x gives us negative 6x. And negative 6 times negative 6 gives us a positive 36. So now that we have no parentheses left over, we can combine our like terms. Y equals, nothing combines with x squared, so we have x squared. Negative 6x minus 6x becomes negative 12x. Be careful on your addition and subtraction. Then we have a positive 36. Now that we have factored form and standard form, we can find all of the information. So to find our x-intercepts, we take from factored form our linear factors of x minus 6 equal to 0. We get x equals a positive 6 because we add 6. But then we also have the x minus 6 here equal to 0, and we have x equals positive 6 again. So in this case, we have the same x-intercept, meaning that we really only have one x-intercept, one distinct x-intercept, but it does happen twice because what's happening is that the graph is going to bounce at that x-intercept. That means that it will not cross through the x-axis, it'll just hit it and it'll come back up. So that would be at the x-intercept right there. Then our y-intercept comes from our constant, and we can determine if it's a min or max from the a value from the beginning of either factored form or standard form. So our x-intercepts are at 6, 0 and 6, 0, which you could just rewrite as just the one x-intercept at 6, 0. It does happen twice. We do need to know that it does happen twice, but we only have to write it once. Our y-intercept comes from our constant of 36, so it's 0, 36. And we determine, since the a value in the beginning of factored form and standard form is positive, this is a minimum. So x minus 6, all that squared, turns into y equals x squared minus 12x plus 36. We have the x-intercepts at 6, 0 and 6, 0, or just 6, 0. We have the y-intercept at 0, 36, and it is a minimum vertex. For question 6, we're going to rewrite this into standard form. So we can multiply the beginning value into the first set of parentheses. So we'll have parentheses negative x plus 2, because a negative times x is negative x, negative times negative 2 is positive 2, and we still have the x minus 5. Now we're going to distribute our first set of parentheses into our second set. So negative x times negative x times negative 5, and we'll multiply their 2 times x and 2 times negative 5. Negative x times x is negative x squared. Negative x times negative 5 is positive 5x. 2 times x is positive 2x, and positive 2 times negative 5 is negative 10. So combine our like terms, we get y equals negative x squared plus 7x minus 10. To find our x-intercepts, we go back to our original factored form of x minus 2 equals 0. We get x equals positive 2. We take our x minus 5 equal to 0. We get x equals positive 5. So our two x-intercepts, they are two distinct x-intercepts, unlike question 5. We have at 2, 0 and 5, 0. Our y-intercept comes from our constant of standard form, which is at -10. So it's at 0, -10. And because the a value in factored form is negative and the a value in standard form is negative, that means that the graph will open down, which makes this a maximum. It will have a maximum point on the quadratic, so it will open down. So y equals negative x squared plus 7x minus 10 has two x-intercepts at 2, 0 and 5, 0. The y-intercept at 0, -10, and it has a maximum vertex. These last two problems are to rewrite into factored form. That means that we were given standard form, and we're going to find our x-intercepts by putting them into factored form. Our first step is to find our greatest common factor. So our smallest number on here is 3. So I can divide 3 by 3, and we can divide 6 by 3. So our GCF so far is 3. Then we look, we have an x squared and an x. Both of these terms have an x in it, so that means I can factor out a 3x. That means I need to divide everything by a positive 3x, and I have to keep that 3x multiplied. Because remember, we are dividing, so we have to rewrite it as a multiplication. We're left with the inside being 3x squared divided by 3x is just positive x, and positive 6x divided by positive 3x is a positive 2. We look to see if we can factor this any further on the inside by doing, since there are two terms, a difference of squares. We have a linear x here, therefore we cannot factor this further. Because this is an x to the first power, we cannot factor this any further because we factored out our GCF already. So we actually have it as y equals 3x times x plus 2. This is as factored as it gets. So in factored form, this is y equals 3x, parentheses, x plus 2. To find our x-intercepts, we take all of our x values, so our linear factors, which also include that 3x, because this does include a 3 times x. That's the first one we take. We take our 3x and equal it to 0. We divide by 3 in this case, and we get x equals 0 divided by 3 is 0. So if we think 3 times 0 gives us 0. The other one comes from our x plus 2. We set that equal to 0, and we have x equals -2 because we subtract 2. So our two x-intercepts, we do have two distinct x-intercepts, which are at 0, 0 and -2, 0. Our y-intercept comes from our standard form, our constant, which in this case, there was no constant. So the number that represents our c is 0. It has to have a y-intercept, so that number for our constant is 0. So it would be 0, 0. We need to determine if it's a minimum or maximum. Since our a value is a positive 3, and we still have a positive 3 here, this would have a positive a value, meaning it opens up, so therefore it is a minimum. So it turns into a fact form of 3x times x plus 2. We have two x-intercepts at 0, 0 and -2, 0. The y-intercept also is 0, 0, and it is a minimum. This last problem also asks us to put it into factored form, so that means we need to look for our GCF first. GCF, since our first term is negative, that automatically means that we have to bring out a negative for our GCF. Because your a value is negative, you always factor out a negative. Our smallest number is 2. So 2 can be divided by 2, and so can 8. So our GCF is -2 so far. Then we look at all of them to see, do we have x in the first one, but we have no x in the next one. So our GCF is just -2. So we're going to divide everything by -2. We're going to put that on the outside of our parentheses because it's really a distribution. we're going to be left with positive x squared and a negative 4. We still have to determine if we can factor further by looking at the inside the parentheses. We look for what's called, since there's two terms, we look for a difference of squares. X squared is a perfect square, and 4 is a perfect square. There's also a subtraction. Therefore, this is in fact a difference of squares. So this will factor automatically because this is a difference of squares. This turns into negative 2 parentheses, so 2 sets of parentheses, x and x, and then the square root of 4 is 2. We have 1 positive, 1 negative. The square root of x squared is x. The square root of 4 is 2. We put 1 positive, 1 negative. So to put this into factored form, we would have y equals negative 2 parentheses x plus 2 close parentheses, parentheses, x minus 2. This is now in factored form. We do have to make sure that we're always extra careful when we're factoring to see if there's anything extra we can continue to factor. To find our x-intercepts, we take from our linear factors. So the negative 2 does not have an x. The first set of parentheses does, so it's x plus 2 equals 0. We get x equals negative 2. Then we have x minus 2, so we set that equals to 0. We get x equals positive 2. So our two x-intercepts are at negative 2, 0 and positive 2, 0. Our y-intercept comes from the original form. We have a positive 8 as our constant, so we always go back to our original. So before we had even begun to factor it, our original had a positive 8 for the c because it was constant. There's no x attached to it. So our y-intercept is at 0, 8. And now we determine if this is a minimum or maximum. The a value was a negative 2 from the beginning, and we still have a negative 2 in the front. So since it's a negative, it opens down, which means our vertex is at a maximum. So our factors are y equals negative 2 times x plus 2 times x minus 2. Our x-intercepts are at negative 2, 0 and 2, 0. Our y-intercept is at 0, 8. And we have a maximum because our a value is negative.